Solving for a specified variable. So what does that mean? It means to rearrange the formula to isolate the specified variable. Really what you're doing is you're undoing the process of PEMDAS. So PEMDAS says to do the parentheses and the exponents, the multiplication and division, and then the addition and subtraction. You are actually going to work your way backward through PEMDAS when you're doing this. So first you're going to undo the addition and subtraction to isolate the term, and then you're going to undo the multiplication and division to isolate the actual variable. So in this case, they want us to solve for C. So if I were to write my equation, this is the one they want us to get all by itself. That's a negative C because this negative sign is in front of it. And so I have to undo the addition and subtraction. So I have to undo this S, which happens to be positive since there's no negative in front of it. So I'm going to remember that my equal sign is my balance scale, and I'm going to subtract S from both sides of the equation. And since these are not like terms, I just have to say M minus S. That's your zero pair, it cancels, and you get a negative C. And so the only other thing that you need to do in order to isolate the C is to make sure that it's positive. So I'm just going to either divide the whole equation by -1 or multiply the whole equation by -1, and that just changes the sign. So negative M plus S equals C. So I have isolated C to equal negative M plus S most of the time in the book or in any kind of situation. Simplifying this, we would put the positive term first. So S minus M is essentially the most preferred way to write that answer. Okay? Looking at the second one, we're solving for R. So again, if I rewrite it, I get I equals PRT, and I think you would all agree that there's multiplication happening between each of them. And in order to undo multiplication, we need to divide. So we're going to divide by both P and T because I don't want either one of them left. And any number divided by itself or any letter divided by itself is 1. So that's just going to leave the R on the right-hand side. And it is going to be equal to I divided by PT. And that is going to be the algebraic expression you are left with because we don't know the values of these. Okay, looking at this last one, we're solving for n. The problem is n is within some parentheses. We need to isolate that in order to undo the parentheses. So the first thing you have to do is divide by the term outside the parenthesis to get rid of it. So now I have A over P equals 1 plus Ni. And this is the term that has the n in it that I'm trying to get by itself. So I have to undo this, subtract 1. A over P minus 1 equals n times I, and then divide by I in order to get the n by itself. Okay, so we get A divided by P minus 1 over I equals n. Okay. In this last one, for P, I want P by itself, which means if it's in a fraction, I need to get rid of that fraction. And we talked about how do you get rid of a fraction? Well, you multiply by its denominator. So P equals I times V. All right, so you are isolating the variables. Now, formula rearrangement is a way of devising variations of formulas. What does that mean? Well, first of all, why do we solve for these specific? Why is this the one we want to solve for? Well, a lot of times we're using formulas and we're solving for things. Like if you're looking for the interest on a house, let's say, you want to keep saying, well, how much is the interest on this house? Well, how much is the interest on this house? And you keep changing the values of the numbers you're putting into the equation. And it makes most sense to do that if you're always solving for the same variable in the equation and it's in a really weird place, to isolate the equation first, manipulate the equation first so that variable's isolated all by itself, and then you can very easily plug numbers into the rest of it and get that value out each time without having to constantly be redeveloping that equation each time. So you turn it into kind of a plug and chug situation where you plug the numbers in and chug out the answers without having to manipulate the equation because it's already sort of manipulated for you. So that's the usefulness of the formula rearrangement. Okay, so if you are repeatedly solving for the same variable isolate it first, isolate or solve, right, for it. Okay, then it's plug and chug. And I say plug and chug a lot because it really just means you're plugging in some values and then you just have a numerical sentence and you just need to calculate or chug out the answer. Okay, part B, select a formula that has at least 3 variables. Find a variation of the formula for each of the 3 variables of the formula. So I'm just going to make up a 3-variable formula. So M equals RT over P. And I'm going to solve, oh, that's 4 variables. Sorry about that. Get a little crazy with my variables. One too many variables. I'm going to do instead M equals R over P, and says to solve for each. So I have M equals RP. That one's already solved for. In this one, I'm going to solve for R, which means I have to multiply by the denominator. And so I get PM equals R. So this is the first one. M is all by itself. In this one, R is all by itself. And in the last one, I'm going to get P all by itself. So M equals R over P. Again, multiply by the denominator. PM equals R. And if I want P by itself, I'm going to divide by M. So P equals R divided by M. There's the third one. So you can see if I have to keep repeatedly solving for for R in this equation, I would have to every time put my value of P in here, multiply, get the answer. And it's so much easier if you can just keep plugging in here. That's where all your numbers are and telling me what the answer is instead of having to put the numbers in here and then multiply by that number on both sides to then get the answer. Just do it in one step. Same thing here. Just do the multiplication or the division every single time instead of multiplying both sides and then dividing.